Question number 4, Molly Beth invested $33,231 in savings bonds with an annual interest rate of 4.6% compounded 12 times per year. After how long would there be $43,770.30 in Molly Beth savings bonds? Start off with our growth formula, exponential growth. C sub n is equal to C sub 0 times 1 plus I to the power of n, where I is the interest rate per compound and n is the total number of compounds. And the total number of compounds is the number of compounds per year times t, the number of years. The number of compounds per year is 12 compounds per year. We don't know how long t is. We're going to solve for n, and then once we solve for n, then we're going to figure out what t is. We know that m is 12, and we know that I, the interest rate per compound, is the annual interest rate divided by the number of compounds per year. The annual interest rate is 4.6%. Divide that by 12. 4.6% as a decimal, divide by 100, so move the decimal point over twice. 0.046 divided by 12, and that gives us 0.00383 repeating. Handy dandy calculator time. 0.046 divided by 12 is equal to 0.00383 repeating. Keep that number in your calculator. We know the n is n, and we know the I is really 0.00383 repeating. I can add 1 to this, and that's going to give me 1.00383 repeating. And the C sub n, the final amount, is $43,770.30, is equal to the initial amount, which is $33,231, times 1.00383 repeating to the power of n. So I want to get all of this stuff alone. I want to get the n alone as much as possible. First thing I'm going to get rid of is the $33,231. It is multiplying this bracket, so I'm going to do the opposite. I'm going to divide by 33,231. But if I divide the right-hand side by 33,231, I also have to divide the left-hand side to keep everything balanced. We're going to do this division. This division just becomes a 1. Anything divided by itself is 1. 43770.30 divided by 33231 is equal to 1.3175265, and it goes on forever. Keep this number in your calculator. Don't round this, and write the rounded version here, but keep the number in your calculator. This cancels, becomes 1. We're left with 1.00383 repeating to the power of n. N is our exponent. Whenever you have your unknown, your variable, as an exponent, you're going to switch to logarithmic form. And we remember Renee's formula that said if you have some answer is equal to a base raised to an exponent in logarithmic form, we're taking the log of that answer, so log of the answer to the old base b, is equal to the exponent. The log of 1.3172 to the base 1.00383 repeating is going to be equal to n. That looks like a negative. It's really the repeating on top of the 3. I can rewrite this using our change of base law that says if you have the log of a to the base b, we can rewrite that as the log of a divided by the log of b to any base. Base 10 is going to be the base to pick. And when it's base 10, we don't even bother writing the 10. It's just implied. Log of a divided by the log of b. The log of 1.3172 goes on forever, divided by the log of 1.00383 repeating. And we end up getting n value, so handy dandy calculator time. This number, keep it in the calculator, so take the log of that number, divided by 1.00383 repeating. I'm just going to hit 3 a whole bunch of times. That number, take the log, divided by 1.00383 repeating. Log of that equals 71.999999. Okay, that's 72. So close to 72, it's 72. We're saying that n is equal to 72. Remember, n is really m times t. 72 is m times t. M is the number of compounds, which is 12. 12 times t. Times what is 72? Times 6. Or divide both sides by 12. You could do that as well. 72 divided by 12 is 6. So 6 is equal to t, or t is equal to 6, same thing. We know it's going to take 6 years for Molly Beth to accumulate all of this wealth. There would be $43,770.30 in Molly Beth savings bonds after 6 years. And that's it for question number 4. Have a good day.